Hey there, environmental science class. Mr. Rising here in a cold and chilly Sunday morning at the high school. The heat's not on, so they keep it pretty cold here. You're looking at Mr. Rising what he looks like outside of school time normally, but I thought I'd demonstrate to you how this biome project is supposed to work by giving you an example. And actually, this will be part of the whole unit on ecology, and that is. We're going to be talking about the intertidal biome. So just so you're aware, I am going right along here. I'm following my guidelines, looking at the format, citations, and then the different content categories to make sure that what I'm providing to you is a legitimate example of what you should be doing. So here we go. I'm already 47 seconds in. I got to keep it to 12, and I'm shooting for 10. It's a photo from that I took from here forward. You'll see it cited as GBSR if I took the photograph of Moosehead Point, which is across the bay from Homer, at a -5 tide. And it's just such an amazing place to be able to walk out and explore this world that gets covered by the tide at least twice a day. So here's my title page, and it is called the Intertidal or Littoral Biome. All right, so let's just start getting right into it. I'm going to start off, first of all, with abiotic factors, because what makes the intertidal zone so different than any other biome is the fact that it is constantly changing. It's not like day and night. You've got day and night as a component. You've got a variety of moisture. Sometimes it's dry, sometimes it's wet, sometimes it's salty, sometimes it's rainy. You've got a variety of water movement. You've got certain areas that are just so calm and other areas that are just getting pounded by the surf, and some areas that happens both. During a storm, they get really stirred up, and so few places go through these extremes. Of course, another one is temperature, and when we're talking about the climate of a intertidal or littoral biome, really, we're talking about a range of temperatures that's quite mild. We're looking at like rarely of an average temperature over 70 and rarely a low temperature climate-wise below 40. But really, within any given weather pattern, it can get a lot more extreme. For example, on a sunny day when the tide is out, those tide pools can get cooking well over 90 degrees or 100 degrees, especially along Mexico or in dry regions. The flip side of that, of course, is when it is freezing cold and you've got a low tide at night. I mean, it can be almost 0 degrees in some of these tide pools, and that will kill off a lot of light. So on my list of key things here, of course, is vocabulary. And one of the ones we need to keep in mind is salinity. And salinity is the amount of salt in the water. So very little water actually has no salt content, but ocean salt water is about 3%. I'm going to pull in a few more terms here real quick. So these physical factors continued, abiotic. The substrate, is it mud on the bottom? Is it cobbles, sand, boulders? Of course, the slope, the steepness of the shore, the amount of time that an animal or a plant is exposed to when they're not in the water. These changes in moisture are huge. And of course, the turbulence, how turbulent things are getting shaken up and mixed around. I mean, it's really just awesome. Those are called abiotic factors. But when we look at biological factors, you can think of those things as the competition within a habitat for resources, predation, when another animal comes in that eats the other one, the availability of food, right, and the ability of organisms to move. I'm going to throw in just a real quick 20-second film, and I thought you should see this. This is actually McDonald's Ketchimack Bay. It's a time-lapse photography. I don't encourage you to put videos within your video, but this might be just a nice example of a 20-second film. It was posted by Turquoise Periwinkle, and that's my citation. Check this out. So you can see we're just cruising through. You can see the tide coming in the background here, starting to flood, starting to flood. Check it out. Birds go by. Here comes the water. People go by. Look out. Get out of the way. Oh yeah, here come the boat is floating. Isn't that cool? Yeah, anyway. All right, so I'm going through my list. I don't want to spend a lot of time in this video talking about tides because I'm already halfway through. So I'm not going to go into too much detail about how the tides work, but obviously the tide is the biggest factor in the intertidal zone. Now, one of the things I want you to include in your abiotic factors are the geographic ranges. Of course, if you follow my cursor here, anywhere that my mouse is going over where the land meets the sea, you can have some sort of intertidal zone, but the areas in red have the most significant tides in the world, and those are the ones we really need to focus on because that's where you'll see the greatest changes. Now, when we talk about an intertidal zone, again, they're broken into various littoral levels. Okay, so you've got an area that's called subtidal, which is never out of the water. Of course, that's where fish are primarily going to live. You have a lower intertidal zone, and in these areas here are where you're going to find, we're talking about plants or things like kelp, seaweeds, sea lettuce, corals, sponges, there's the fucus. There's so many different kinds of seaweeds and whatnot. You get into a middle intertidal zone, and that's where you find it's not quite equal time in and out of the water, but it's getting closer to that. The upper intertidal zone is mostly out of the water most of the time, but occasionally it gets inundated, which means you can't find trees here. You can't find terrestrial organisms that can't hold or that can't have salt in them. Of course, the other one is supratidal fringe. This is also known as the splash zone. So some organisms can not only handle salt water, but take some of that salt water for their own moisture. But they have been specially adapted to this zone. All right, I'm already at 7 minutes. When we're talking about various organisms, of course, barnacles, periwinkles are ones that are in that upper intertidal zone. That splash zone is primarily lichens, which is neither plant nor animal, but a combination of a fungus and an algae. The middle intertidal zone, and I've taken all of this from books. I've copied a book called Southeast Alaska's Rocky Shores. That middle zone, it again is featured by limpets, mussels, some sea stars, periwinkles. As we drop down even further, now you're getting into stars that don't move so quickly or can't stay out of the water as long. Again, your algae start to show up there, red algae, chitons. If you've been out with me, we've found chitons before. Now, when we get into that extreme lower intertidal zone, well, that's where we find our treasures. So here are examples of a clown nudibranch. This is called a sea mouse. These are my photographs. This is a lemon nudibranch. You see a lot of these in the Seward area. So when we do some tide pooling at night for extra credit, make sure you're along for the trip to take a look at it. So I think I've done a pretty good job here at talking about animal life, plant life, abiotic factors. So what I need to still focus on is the food web or trophic levels, human influences, and current affairs. So let me just jump into this right away. Hey, there's a lot of information out there that already have food webs on it. And the idea here is producers. Primary producers are things like phytoplankton. And I'm going to show you this in a couple more slides. Of course, phytoplankton are eaten by zooplankton. Zooplankton are single-celled animals, right, that eat the single-celled plants. That's one example. And then those single-celled organisms get eaten by primarily filter feeders, but grazers can definitely get like algae and whatnot, and that's a big thing. Of course, then other organisms like carnivores, like sea stars, birds, etc., come and devour the grazers. They devour the filter feeders. A lot of them get eaten by, I was thinking crabs and whatnot can also be eaten by birds and other things. So there's this sort of web, and of course as everything poops and everything gets broken up, all that detritus gets mixed back up and it is recycled. Nature wastes nothing. Here's another example of a food web when you add a sea otter to the mix. And again, if this was my presentation, I wouldn't have spent as much time explaining the process. But this is another great example of how food is produced on a microscopic level and how just one form of nutrients is distributed among a whole community or a whole biome. Now here is a classic trophic level. Now this is a 5 level, again with phytoplankton on the bottom, zooplankton above, shellfish. A lot of shellfish are filter feeders, and they are eating the zoo and the phytoplankton. Of course, then otters come in and eat the shellfish, and then humans or orcas or other organisms predate on otters. Now we don't necessarily eat otters, but we have been known to use them for other things. And that's a nice tie-in, and please use these tie-ins in your project, because when we talk about human influences, you know, the Russian fur trade was a big one. That definitely had a major impact on the intertidal zone, because by removing a primary consumer or you know, a keystone species that really altered the intertidal zone. This is a photo of the trade from Wiz Science. Another one, of course, is oil and gas development and subsequent errors that go wrong, or you know, when things go wrong, the Valdez oil spill and the cleanup effort that ensued. And of course, commercial fishing. I mean, this is another thing that has both pros and cons. I mean, it creates habitat for organisms that aren't being harvested, but it also can add a lot of pollution to an area and introduce different organisms. So right now I'm at 11:47. I'm about to go over my time limit, but let me touch on one more thing. And again, I give myself extra credit because I'm explaining to you the process. But current affairs. So the last part of your talk is, or your presentation is current affairs and research. And this is where I've got some personal experience. Of course, sea level change is a huge deal with climate change, because as cities are having to relocate or to think about rising sea levels, that's a big deal that's going on in the world. And of course, that's going to have a big effect on our intertidal zones, right? Shifting those zones up is going to have a big impact. Glacial rebound or isostatic rebound is something they're doing across the bay from Homer. And what's happening is, as the glaciers are melting, the land is rising. And so what's happening is that at the rate that the seas are going up, the land is rising. So they're not seeing a net change in sea level because the land is rising as the sea level is also rising. Another one, I haven't given you this article, but we should maybe talk about it here. It's called Sea Star Wasting. And this is a photograph of a leather star that doesn't look good. They shouldn't be white and splotchy like that. The red spots are normal, but all that white, it's like it's decomposing while it's still alive. And that has been linked to a virus. It's not necessarily anything to do with humans. It could have something to do with ocean acidification or a virus or whatnot. But they have been able to identify the virus that's been going on. So I hope you appreciated my spiel. I'm sorry it's so long, but that's all we're going to do for now.